continue with our lesson. Now what we're going to do is we're going to develop a formula. So we're going to pretend almost like we're Greek philosophers and we're studying different shapes and we're going to come up with some new discovery. Okay, so pay attention because you maybe have a different way to do this. Okay, so interior angles in a polygon. So in any shape. Now we're going to start with some shapes that we already know. So for instance, a three-sided shape obviously is a triangle. And you know that the number of internal degrees, if I added all the angles in a triangle, it always equals 180 degrees. Okay, so we know that. So we're going to put that in here. Come on, 180 degrees. We also looked at four-sided objects, and remember what we did is I cut it and it made two triangles, and so we knew that that was 360 degrees. Now, what about a five-shaped object? How many degrees would that be? Well, I could again actually divide into shapes, into triangles, because I know what triangles. So there's one triangle there, another triangle there. So we have three triangles have been created. So that'd be 180, another 180, another 180. So if that's the same as going, oh, it might be easier for us to go 3 times 180. And when we do that, we end up with 540 degrees. Now, what about a six-sided shape? Six-sided shape. Now, I don't believe I have a six-sided shape. Maybe I do. Oh, I do. So let's bring up six-sided shape for us to play with. And then I'm going to do the same thing there. I'm going to actually create triangles. So we've created one. Here's another one. Here's another one. And so we have one, two, three, four triangles. Now, you're saying, yeah, but that one in the middle doesn't count. Well, actually it does, because if we look closer at it, the angle for this six-sided shape includes the angle of that middle triangle. So now we have four triangles, so that's 4 times 180 degrees, which when we take our calculator or our head is 720 degrees. Now we've got an issue. I don't want to keep drawing a million different shapes. Okay, so if I look at n sides, what would the formula be for figuring that out so that I don't have to keep drawing shapes and turning them into triangles? Well, let's try to take a closer look. So I want to find some kind of relationship, since my pen stops moving around, between the number of sides and its angles. Number of sides and its internal angles. Well, we could see here that what we ended up having was when it was four sides, we went 2 times 180, right? That was 360. When it was five sides, it was 3 times 180. When it was six sides, it was 4 times 180. So what did we do each time? Well, it looks like we took the number of sides, subtracted 2, and multiplied by 180. So it looks like we took number of sides. We're going to test this out first. Number of sides, subtract 2, and then whatever we got with that, we multiplied by 180. Now let's see if that works. Okay, now I'm going to switch colors just so we can test out our theory here. Okay, so number of sides for this one would be 3. According to this, I should take away 2 and then multiply by 180. Well, 3 take away 2 is 1. 1 times 180 equals 180. Okay, what about this one? We had 4 sides. If we take away 2 and multiply it then by 180, 4 take away 2 is 2 and multiply it by 180. Okay, so it worked for those two. What about the next ones? If I had 5 sides, I take away 2 and multiply by 180. Again, we get 3 times 180. So it looks like this is the pattern that we want. 6 sides, take away 2, which is 4, and multiply by 180. So we ended up coming up with a relationship between the number of sides and the internal degrees. So how would we make a formula? Well, our formula is number of sides, take away 2, times 180. Okay, so that is actually a formula. Or you could write it as 180 times n minus 2. Okay, so that's a formula. Or you could actually distribute it through if you really wanted to, and that would work as well. So let's use that formula now. And as I said, it doesn't matter which one you remember. Probably if it was me, I'd probably remember number of sides, take away 2 times 180, because that way I could check it for a triangle, and I know that my answer has to be 180. So it says, what is the sum of the internal angles of a 20-sided figure? Now, obviously, we wouldn't want to make a 20-sided figure. So let's try to do this now. So number of sides, take away 2 times 180. So that's going to be 20, take away 2 times 180, which equals 18 times 180. And I'm assuming that you would probably pull out your calculator, so we'll pull out a calculator to do it. And I'm just going to go pick up an actual really easy calculator. There we go. Doesn't matter what one we use. So we have 18 times 180 degrees. So we end up with 3,240. And get my pen up here, 3,240, and it would be degrees. Okay, now that's really, as long as we remember, number of sides, take away 2 times 180. So that's going to be 12, take away 2 times 180. So in this case, it's going to be 10 times 180. And you better not pull out a calculator for this one. So that's going to be 1,800 degrees. Okay, so that's as simple as it is. Now, if you happen to forget that and you were asked a question, you could actually come up with the formula yourself because you helped me, okay? You helped me do it. And that's how years ago, centuries ago, mathematicians, usually Greek, actually came up with these relationships that we now use today. Have fun!